Hi guys, in this video I'm going to show you how to work out the electron configuration of any element on the periodic table really quickly. And you'll need to be familiar with this method in order to understand noble gas shorthand. So the first thing I'd like you to do is take a blank periodic table and annotate it like this. So what we need to do is divide it into the three blocks, S, D and P, and then down the side number the different periods, in other words the rows of the periodic table. Something else you'll need to be aware of for this exercise is the order of filling of orbitals and subshells. So the Aufbau Principle states that electrons fill lowest energy orbitals and subshells first, and this order is fixed. And if you're studying electron configuration at college, then you won't need to learn beyond 4p. So we need to know not only this order up to 4p if we're at college, but also the maximum number of electrons that can fill each subshell. So the S subshell only has one orbital in it, and each S subshell can hold a maximum of 2 electrons. The P subshell contains 3 different orbitals. Each orbital can hold 2 electrons, and since we've got 3 of them, 3 times 2 is 6. So the maximum number of electrons each P subshell can hold is 6. Then the D subshell consists of 5 d orbitals. Each can hold 2 electrons. 5 times 2 is 10. And that is all we need for now. So we've labelled the 3 different blocks of the periodic table. We've labelled the periods, and we have our order of filling of subshells along with the maximum number of electrons that each one can hold. Now, the next thing to be aware of is that the period number, so the number of the row, tells us about the shell that an element's outer electrons are in. For example, if we pick an element here, it will have its outer electrons in the second shell, or second energy level, n equals 2. If we pick an element here, it will have its outer electrons in the 6th shell. So what I've done here is labelled the S block. Now, this shows us the subshell that an element's outer electrons are in, along with how many electrons are in that subshell. So the S subshell, there's only one S subshell per energy level, and there's only one S orbital in the S subshell. Now, here we're in period 1, 1 S, because we're in the S block, 1. Here in period 2, these elements' outer electrons are in the 2s orbital. This element here has 1 electron in this 2s orbital, and this one has 2. So we're just counting down with the period numbers, and across tells us how many electrons each one has. 1, 2. Next, we're ready to label the P block. Now remember, there's no P subshell in the first energy level. On some periodic tables, this element, which is helium, which has the electron configuration 1s1, 1s2, or in other words just 1s2, in some periodic tables it's placed over here, and in some it's shown over there. So we know this isn't part of the P block because there is no P in the first shell. And 2 electrons can occupy the S subshell. So this is the 1s2, this is helium. And the P subshell starts in the second energy level. And all we do is the same as we did with the S. The number in front is the same as the number of the period and the same as the number of the energy level or shell that the element's outer electrons are in. And then we just count across for how many outer electrons that element has in this P subshell. So as you can see, all the noble gases have a full P subshell. Now we're ready to annotate the D block. Remember, from the order of filling of subshells, the 4s fills before the 3d. This is because the S subshell is lower in energy than the D subshell, and this is reflected on our annotated periodic table once we encounter the D subshell in the third energy level. And we can see the order of filling of subshells from our periodic table: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. What does this have to do with noble gas shorthand? So when we look at this periodic table, here in group 8, I've annotated by adding all the noble gases, and it becomes clear why helium is placed over here on this periodic table, because helium is classed as a noble gas. Now we're going to use these two periodic tables to practice writing noble gas shorthand. And I've chosen 3 examples: magnesium, manganese and sulfur. So to start with magnesium, what we have to do is find the nearest noble gas. So we go back to neon and we write the noble gas in square brackets. We're saying that magnesium has as many electrons as neon, plus 3 S2. Then manganese. We go back to find the nearest noble gas, which is argon. We put that gas in square brackets. And then we write what's left. So we're saying manganese has as many electrons as argon, which is here, plus 4s2, 3d5. And then our last example, sulfur, we find the nearest noble gas. It's not argon because sulfur doesn't have as many electrons as argon. We have to go back to something that it has more electrons than. So it's neon. And then we write what's left. So we're saying sulfur has as many electrons as neon, plus 3s2, 3p, 4.